Hello, everyone. I'm Dr. Wang. Here is the question. We want to find this integral x times sine x. Here, we are going to discuss the method integration by parts. This method is very important and powerful, efficient. For this integral, looks easy. When you work on it, it's not that kind of easy. If we use this method, it will be easier. Let's derive the method integration by parts. The product rule. Derivative of f times g equals f times the derivative of g plus g times the derivative of f. Based on this product rule, we integrate the both sides with respect to x. The left-hand side, derivative, integral cancel each other. That's f of x times g of x. The right-hand side, because that's plus. Integral is a linear function. We can separate into two parts. The first integral plus the second integral. Rearrange this equation. We have the formula of integration by parts. Keep this in one side and this move to the other side. We have this here. So the integral of f times derivative of g with respect to x equals f times g minus the integral of g times derivative of f with respect to x. We are going to use this formula to solve our question. Comparing our question with the given formula, the left-hand side. If we pick f of x equals x, f of x equals x, and g prime equals sine of x. On the right-hand side, we do need a g function. Here, that's a g prime. We need to find a g. It's easy to see that g of x equals negative cosine, because the derivative of cosine x equals negative 1. Or negative cosine, sorry, negative sine. So here, negative cosine, the derivative of g of x equals negative sine x, which is sine x. We have all three functions here. We can plug in to this formula. F times g. We have f, it's x, times g, that's negative cosine, minus integral g, that's negative cosine, derivative of f, x, take the derivative, equals negative x times cosine x, negative cancel each other. That's cosine. Derivative of x equals 1, disappear. The integral of cosine equals sine x. Don't forget the constants, c. The integral equals this. Now here is the question. students always ask, how do you know which one is which? That means you pick f of x equals x. If we switch the order, it is the same integral, sine x times x. That means if we pick sine x equals f, x will be g prime. What will happen? So here, if we pick f as sine of x, g prime equals x, imply g of x equals x squared over 2. You can easily check it. Take the derivative. That's take 2 down. That's x divided by 2. That's x. So the derivative of g equals x. Plug in those three functions into this integration by parts formula. F times g, that's sine x times x squared over 2, minus g, that's half times x squared. Then that's f prime. F equals sine x, f prime equals cosine x. From here, we compare the current result with the original integral. This part, cosine, sine, similar, and here x squared over 2. Here's x. It's more difficult. So here, the purpose use the integration by parts method is to simplify original question to help us to find the result efficiently. It is not to make the original problem more complicated. If we do this way, you will see that this is more complicated. If we are repeating, consider cosine is f, and this is g prime. Next time, you will get x to the power 3 term, and more difficult. For this kind of problem, how to solve it? We always pick the power term as f, x to the power, like a 3, 4. When you take the derivative of f, the power will drop 1 each time. If you consider cosine, then cosine, the derivative equals negative sine. That's still there. You cannot cancel cosine or sine. Only x, if you take the derivative, it will drop its power by 1 each time. I'll give you a practice question. Look at this question. Can you do it? Can you apply this formula? Which one should you use? Which one is f? Here we only have one function. Looks like we don't have two functions here. If we consider log x is f of x, we consider g prime is 1. 1 is a constant there. If g prime equals 1, what is g? G equals x. What's the derivative of log x? Equals 1 over x. 1 over x, x, you can easily cancel it. If we use this formula of integration by parts, this problem will be very easy to solve. Here's the answer. You can check it if you can get this answer. That's all. Thanks for watching, and see you next time.